Hi students, this is Unit 2, Day 6, and let's get started. Oops, I didn't mean to do that. Okay. Let's see, sorry. Okay, so our learning goals today are similar to what we did in the last lesson. We're still going to find trig ratios of a right triangle given an angle and using the unit circle. We're going to today be focusing on looking for secant, cosecant, and cotangent and using those functions, those three functions. We're also going to find the angles, including coterminal angles, with a given trig ratio using the unit circle. So we're going to introduce a little something else, but I'm hoping if this was okay, this is going to be just fine because it's kind of going the opposite direction. Okay, we've already talked about that criteria for success, so let's go ahead and dig right in. So this is saying we want to find the cosecant of 5/4 pi. Now, something that we talked about but I didn't have written down last lesson is your answer should be exact. This is why we're not just popping something into the calculator. We want the exact value, no rounding, nothing lost. And we want to make sure that we're simplified. So this means we're going to rationalize if needed, okay? So just to remind you of that for simplifying. So the first thing we're going to do is draw that unit circle and get that angle inside. So let's go ahead and draw in 5/4 pi. So this, of course, is 4/4 pi. This is 8/4 pi, and we want just 5/4 pi. This would be 6/4 pi. So right in the middle here, this is going to be our 5/4 pi. Okay. The next thing to take a look at is think about our quadrant that the angle is in. So this is in the real angle here, not the reference angle. We're talking about the actual angle 5/4 pi is in quadrant 3. Now, let's think about the SIGN of cosecant. Do you remember that cosecant is the reciprocal function of sine? So let's think about this. This is negative, negative. Sine is always that y value, and if it's the reciprocal of a negative number, it is still negative. So that SIGN is still the same there. Okay. Let's see, calculate the reference angle. So that's our next piece. Let's do this maybe with a little highlighter here. So this little bit here is the reference angle. So if we want to think about the reference angle, we could say, all right, how about 5/4 pi, take away the 4/4 pi, and we would be left with just a 1/4 pi. Now, probably you can actually see that when you're looking at this. We went from 4/4 here to 5/4. That's a distance of 1/4. That would be the angle measure. Excuse me. So we're going to go ahead and draw in a right triangle. Remember, you need this point. We're going to get right up here, and that is our right triangle. Now, as always, I'm going to redraw this because it gets too crowded. Okay, so we've already talked about this is pi over 4, and we know that's a special right triangle where we have this isosceles right triangle. Okay, this is our 1. These sides are exactly the same. That's our special right triangle. So if we were thinking about this angle and we wanted to find the cosecant of this angle. So remember, sine is going to be the opposite over the hypotenuse. So if this is cosecant of pi over 4 is 1 over radical 2 over 2. Now we can't leave it like this. We want to clean this up. So if I'm dividing by a fraction, that's the same thing as multiplying by the reciprocal. So that's the same as saying 1 times 2 over radical 2, which is 2 over radical 2. And then, what a pain, we can't leave it like this, right? We need to rationalize. So this is a quick little step. It's not bad. Remember, we're really multiplying by a fancy number 1. Okay, it looks crazy, but it's really just the identity. So we're not doing any magic here, we're just doing math. So we have 2 radical 2 in the numerator, just a 2 in the denominator, because remember it's radical 2 times itself, which is radical 4, which is just 2. And then these cancel. So, whew, all right, all this work here, the cosecant of pi over 4 is radical 2. But I didn't want the cosecant rather, excuse me. I didn't want the cosecant of pi over 4. I wanted the cosecant of 5/4 pi, right? So in this case, we know it has to have a negative value. So this is going to be negative radical 2. So we use this reference angle and this special right triangle with the reference angle in it to get the correct ratio. And then we apply the sign depending on which quadrant the actual angle resides in. Okay. Let's go ahead here to this next one. So this is saying cotangent of 7/6 pi. We want cotangent of 7/6 pi. All right, let's go ahead and draw it. Let's get that unit circle. And let's draw our angle. So for this one, we know this is 6/6 pi. Oh, this is boring. I'm back in that third quadrant. Oh, well. And so this is our angle, 7/6 pi. So we are in, again, quadrant 3. Now, this will get a little more interesting. Notice here that the x values are negative and so are the y values. Remember, cotangent is the reciprocal of tangent. And just as a little side, remember we talked about tan of theta is the same as sine theta divided by cosine theta. And remember, we also talked about sine is that y coordinate, sine of the angle, and cosine of the angle is the x coordinate. So if we think about this being down here, no matter which way this fraction goes, a negative divided by a negative is a positive. So we are going to have a positive value, okay, for that cotangent of 7/6 pi. All right, so we have the quadrant, we have the SIGN, and now we need the reference angle. So that's this little guy right here. The reference angle is going to be just 1/6 pi. It's just that little piece. We went from 6/6 to 7/6. The reference angle is just 1/6 pi. So we draw in that special bright triangle. I'm going to blow it up over here. Okay, we just said this was pi over 6, which means this has to be pi over 3. That's our special right triangle. The tiniest angle has the tiniest side. This, of course, is 1 because we're in a unit circle. And this is radical 3 over 2. Okay, again, here's the angle we're looking at because we're just in this little special right triangle with that reference angle. So if I wanted the cotangent, instead of the opposite over the adjacent, I'm going to do the reverse. Cotangent of 1/6 pi, oopsies, equals, so again, instead of the opposite over the adjacent, we're going to say the adjacent over the opposite. This is the same as multiplying by the reciprocal. So radical 3 over 2 times 2 over 1. These cancel, and I'm left with radical 3. Now, we really wanted cotangent of 7/6 pi. It's this same ratio with the sign applied. So in this case, it's exactly that same value. Remember, this is cyclical. You will have a lot of repeating values around that unit circle. Okay, now this next little part I'm going to show you is solving for an angle measure given a trig ratio. We're going to still use the unit circle and the right triangles. So we'll identify the quadrant or quadrants where the angle or angles would be drawn. We will use the appropriate special right triangle to determine the reference angle. and we will use the reference angle to determine the angle measure or measures. So again, we will not memorize this, but we want to think about the patterns, right? So this, if we look here, this is talking about this space on the x-axis. It's at a positive radical 3/2. And then mirror image over here is a negative, which makes sense because it's to the left. Now let's see if we look down below here. This is a positive because again, these are symmetric. They're lining right up. Those are both positive distances from the origin. And the same thing over here. If we're looking here and here, we have that same distance, negative radical 3/2. So you will see a lot of pattern recognition, and again, just using those special right triangles. All right, so here's what this question is going to look like. Find all angles within 0 to 2 pi with the given trig ratio. So remember, this cycle is going to go on forever in both directions. Think of your sine function, right? Forever and ever and ever. I only want to know within one revolution. Sometimes I'll say more, but in this case, we're just looking from 0 to 2 pi. So we want to find, your goal is to tell me what is theta, okay? We know that sine of theta is negative radical 3/2. Okay, so if sine is negative, that means we're looking down here. Okay, we're looking down in quadrant 3 or quadrant 4. And radical 3/2, doesn't that look like one of our special right triangles? Pi/6, pi/3, and so this is our 1/2, our 1, and our radical 3/2. Now let's think about this. Sine of which angle gives you radical 3/2? Sine of which angle? Sine is opposite over hypotenuse. So it's going to have to be pi/3 because that will be the opposite over the hypotenuse. So now we know the reference angle has to be pi/3. So we know the quadrants 3 and 4. So it's kind of like we're playing detective here. We know the quadrants, we know the reference angle. So let's think about what the heck angles would these be? Both of these little spaces are pi/3, that's the reference angle. So let's think about this. If we're talking about thirds, this is 3/3 pi, this is 4/3 pi, and 5/3 pi. Both of these, if we're thinking, again, we're thinking our unit circle, both of these would have that same negative distance on the y-axis. So you're going to say, okay, Mrs. Wojcik, theta is going to be 4/3 pi and 5/3 pi. Both of those angle measures, if I put that in for theta and I take the sine of those angles, I will get this output. So this is where we're going to move backwards. Okay, now here is a little trickier one. So this is saying the secant of some angle theta is 2. All right, now we're going to kind of work backwards here. So we have our unit circle. Okay, and we want the secant of some angle equal to 2. Again, we're just going in one revolution. Okay, so again, eyes on the prize, what the heck is theta? We want to know, what is this angle measure? Now, secant is a reciprocal function with cosine, and this has a positive output. Where is cosine positive? Where are the x values positive? In quadrant 1 and quadrant 4. Okay, now let's think about special right triangles and which one makes sense for this. So let's say we think pi/6, pi/3. Let's see if we can get this rolling here. And 1. So that's our special right triangle. Okay, we want to know which angle, if I take the secant of it, will I get 2. So now cosine is adjacent over hypotenuse. We want hypotenuse over adjacent. And hopefully you can see 1 divided by 1/2 will actually be 2. So this is the angle that is our reference angle. Okay, so we would say, just to show this, secant of pi over 3 is 1 over 1/2, which is the same as 1 times 2, which is 2. So this checks out, okay? This is where we are. Now, again, this is the reference angle. We want to know which angles in the first and fourth quadrant have this same reference angle. Well, of course, if it's in the first quadrant, we're going to be at pi over 3, right? Because that's going to have the reference angle. Now, what about here? How many thirds would this be? This is 3/3 pi, 4/3, 5/3. 5/3 pi. So what you've done is you found the 2 angle measures that would work. Theta is pi over 3 and 5/3 pi. When you plug those values into the secant function, you will get a positive 2. Okay, last one of these, from 0 to 2 pi. Now we're going to take a look at tangent. Okay, tangent of some angle is 1. So, okay, what the heck is theta? So we're looking at just one revolution. Where is tangent positive? Well, let's see. This is positive, positive, negative, positive, negative, negative. Whoopsies. I didn't mean to put a 1 there. And then this is positive, negative. So if I'm dividing sine by cosine or y by x, they have to be the same sign. So that means I'm looking here and here. Now let's think about the special right triangles. Opposite over adjacent has to be equal to 1. And I hope you're thinking of our isosceles special right triangle. So this would be pi over 4 and pi over 4, radical 2 over 2, radical 2 over 2. And if this is the angle I'm looking at, this would be opposite over adjacent. And it doesn't matter which of the angles you look at. If you look at this other one, it would be the same thing. So we would say, okay, tangent of pi over 4 is radical 2 over 2 divided by radical 2 over 2, which is just 1. This is my reference angle. All right, now let's draw in the real angles, the real values for theta. So right here would be, this would be the reference angle pi over 4, that little bit. And then over here, this would have a reference angle of pi over 4. So what are these angle measures? This one actually is pi over 4 radians. This is 4/4 pi radians. So this is 5/4 pi. So the angle measures, this is the big thing what I'm trying to solve for, is what is theta? Theta is pi over 4 and 5/4 pi. And if you plug either of those into the angle measure for tangent, you will get positive 1 as your output. Okay, very last thing I want to go over with you. In a right triangle and given the trig ratio, find the remaining trig ratios. So first of all, I'm telling you this is a right triangle. You're going to just call whichever one of these angles, x or theta or whatever it is, doesn't matter. So it's saying sine of this angle is 2 over 3. Well, with SOHCAHTOA, we know the opposite is 2, the hypotenuse is 3. Your job will be to find cosine, tangent, cosecant, secant, and cotangent. So something we really need to find is that third side. Since we have a right triangle, I'm just going to call this y, we can go ahead and use Pythagorean theorem. 2 squared plus y squared equals 3 squared. We we isolate that y squared, and now we take the square root of both sides. Now, of course, we're only going to take the positive radical 5 because the length cannot be a negative value. Now we have all three sides, and this is still the angle we're looking at. So cosine of the angle is adjacent over hypotenuse. Tangent is opposite over adjacent. Oh, now we got to do a little bit of work here. So now we have to rationalize. So radical 5 over radical 5, which equals 2 radical 5 over 5. So far this was given. We found this one. We found this one. Now, cosecant of the angle is going to be the reciprocal of sine. So this is just 3/2. Okay, reciprocal of sine of x. Secant is the reciprocal of cosine of x. So this is 3 over radical 5. Oh, now we got to do a little more work again. Radical 5 over radical 5, which equals, sorry, I'm kind of squished here, 3 radical 5 over 5. Okay. And cotangent of x is the reciprocal of tangent of x. So this is actually nice. I'm going to take this little green ratio, and I'm just going to reverse it here, do the reciprocal. And now I'm done. So that one we didn't have to do much more to. And those are your 6 ratios. So if I give you one, and I tell you it's a right triangle, you can create that triangle, find the missing side, and find all the rest of the trig ratios. Okay, thank you so much for taking the time to watch this. Please keep track of all your questions, and we will